The sum of the integers in each row and each column below must be the same. 4 integers, including x, are missing. If x must be larger than the other 3 missing integers, what is the smallest possible value for x? So I'm going to start off finding an x and the missing numbers that work such that x is larger than the other 3 missing numbers. And only then am I going to try to optimize x to find the smallest value of x where that's still true. It works and x is greater than the other 3. So let's start by finding one scenario that works. Well, I can see 9, 7, and 4 along the rows. That means the sum of that row is 12, 16 minus 4. The sum of this column, 7, negative 2, and 7, should also be 12 because we know all the rows and all the columns must have the same sum. So for the row with x, well, we've got a 7. It could be possibly, let's guess, a 5 and a 0. X is greater than 0. Okay. Well, if that were the case, I've got 5 minus 4, and that would be 1. I'd have to add something else, which would be 11, except 11 is not a digit. Well, it doesn't say digits. 11 could be an integer, so that would work. And that would in turn mean this would be 3. So 11 plus 3 minus 2 is 12. 9 plus 3 plus 0 is 12. So this works. However, it does not meet the condition that x must be larger than the other 3. So now I've got to modify this and increase my value of x. Let's try a bigger x. I'm going to jump up to, say, x equals 8. And that's 15 across, so I'd have to have minus 3 there. And that would be a sum of 12 along the rows, so that works. That's 12. And then the column here would have to be a 12 sum. So 8 minus 4 is 4. That would mean another 8 there. And for this to be 12, 9 minus 3 is 6, so I'd have to add another 6. So not quite. X equals 8 still didn't quite get us there because x must be larger than the other 3. It's larger than or equal to. That's not the condition. So again, we don't meet that condition with x equals 8. I'm going to have to go higher for x, but we're getting pretty close. So now let's try x equals 9. So if I put in 9 for x, that's 9 plus 7 is 16, so I have to have minus 4 here to get my sum of that row to be 12. 9 minus 4 is 5, so I'd need 7 there to get a sum of 12 for that column. And if I want a sum of 12 for that column, it'd be 9 minus 4, which is 5. So again, I would need a 7. And the sum of the rows are still 12, and that column's 12. It all works. It also is true now, x is larger than the other 3 missing integers. 9 is greater than 7 or negative 4. So far, so good. Now, let's try to optimize this. What's the smallest possible value for x? X is an integer, if we recall. Well, we tried the smaller values up to 8. The first one that worked is 9, so x equals 9 must be our answer.